Hello folks, my name is Sahil Serene and this is a pre-recorded version of my talk at GUADEC. I'll basically be presenting on a tool that I wrote for the games, which is basically a tool that helps you do health analytics on the games. So you can do stuff like find out which modules in the games are broken and also figure out how to fix them. So that's something I'll get back to. I'll start by introducing myself. My name is Sahil Serene, and I've been with the GNOME project for about 2.5 years now. I'm a foundation member, and I mostly help out with games. So two of the games that I have had significant contributions in are mostly chess, and I also do releases for Sudoku now, but yeah, I've been with chess for quite a while. And I've also written some tools. So I write some tools for the games. I'm not sure the screen behind me is visible, but that's the best I could get. So this is one tool that I'd like to introduce to everyone here. So this is a tool that basically checks the code style. So when I started contributing to the games, I saw that there are different games, and each of them uses a slightly different code style. So for people who are contributing to multiple games, it's very difficult to make sure that the code style they follow is consistent. So this was an effort I put in to make sure that the code style of all the games is consistent. So what this tool basically does is whenever you try to do a commit, it will check your diff, and then it'll complain about the code styles that you've violated, and then you can go and fix it. And it also saves the reviewer's time. So this is something I recommend the other GNOME modules to incorporate, but right now it's in use for all the games, and we're really happy about it. So alright, so now let me get back to my presentation. I'll just get it set up in a bit. Okay, so I'll get back to the board here. So that's the topic, and I'll start with the presentation now. Okay, so introducing you to the games. They are the most interesting part for me in the project, and there are a lot of games. There's chess, Sudoku, there's 2048, Mines, Tetravex, and there's more than 20 more apart from the ones I've already listed. So it's very interesting. I recommend you to go ahead and play games, give us feedback, and we can improve upon it. So getting back to the core of this presentation, the health of GNOME applications or GNOME applications. So what do you even mean by the health of a GNOME application? So we have this very nice tool which is GNOME Continuous. So what this guy does is it will try to build each module that is registered with it, which is in principle every module in GNOME, and it will try to build it. It will make sure it will just tell you if the module is good to go or not. So you can see each of these boxes have a green tick mark or a red mark over here. So I'm not sure if that's visible, but please bear with me. So there are two categories that we can clearly see. One is the ones with the green tick marks, and the other one is with the red marks. So the red marks are the ones which need our attention. So we need to probably take a look at the logs for these and figure out what is breaking them. So there's something wrong over here, which means there's either something broken that is being pushed to them, or there are dependencies of these modules which are broken, which are in turn breaking this module. So the developers for these applications need to go back and fix them. So that's the tool that we already have, and my tool is an enhancement on top of what this already does. So going back to the previous slide, we also have this IRC channel testable. So developers are encouraged to be joining this channel, and then you can see you get logs from build GNOME.org, which are successful or failed. So if you see that your module failed, on the IRC you're supposed to go back and try and fix it. So again, so I saw a couple of problems, rather areas of improvement on the tool that we already have. One of them is me as a developer, I'm interested only in a subset of the modules because it's just a subset that I maintain or I'm responsible to maintain. So if I have all of the GNOME modules listed over here, it's a little hard for me to go ahead and check, go ahead and basically look for games modules and then go ahead and try to fix them. So there's more information over here than I'm interested in. So I want to filter out just the games from here. So that's number one enhancement that I want to do. And another enhancement is there's too little data on the screen. So let's say, for example, we can see a game that's broken, that's Mines. So this one in the corner. So Mines is broken, so I see, okay, Mines is broken. I go to the logs, I figure out, okay, so-and-so bad comment was pushed to it. I go ahead and fix the comment, and then come back to this page and look for other games. Let's say there's another game, let's say Sudoku was broken. And then I go to Sudoku and see, okay, this dependency is broken and I need to fix it. But before I make any dependency changes, I need to make sure that there aren't any other games which have a dependency on this that are breaking. So I have a problem now. I need to figure out which games have this as a dependency, and I have like 25 games, and I need to check, or I need to figure out which games depend on this particular dependency which is broken or which is breaking Sudoku, right? So that's another problem. There's no relationship between two different modules which are actually related in terms of the dependency. So there is a dependency, for example, there is a potential dependency, for example, on two games which I cannot see from here directly. So that these are two motivations that led me to build this tool. So, and I was looking for options, and what could I use to represent these relationships? Is there a way for me to have a nice visual tool, just like continuous, but something that gives me just a subset of things that I'm interested in? So I ended up choosing graphs as an option. So for those of you in the conference which aren't familiar with graphs or aren't from a computer science background, you can think of graphs over here for this application as each of the games or each GNOME module being a circle and each dependency, for instance, being another circle. So you can think of the circles being entities like a game module or a dependency for a game module, and then you can think of lines between circles, like lines connecting two circles. So I'd say if there is a dependency that depends on a game, I draw a line between the two circles. If there is chess and Sudoku which have a dependency called A, so there'll be a circle for A, there'll be a circle for chess, a circle for Sudoku, and there'll be a line from chess to the dependency A and a line from Sudoku to the dependency A. I hope I've gotten some background on the graphs over here. So, okay. And then, okay, now I've decided to use graphs because they're very flexible. They meet the goals that I want from continuous. So what next? So now I need a tool that that basically helps me achieve this with graphs. So I find Neo4j as a nice tool which does graph visualization. It also helps me do a ton of other things like taking out a subgraph or a subset of information out there, running queries, and filtering out information that is of my interest. So I'll show this in a demo, but okay, so graphs everywhere. So this is easier to imagine for people from computer science background. So you can see that everything in the world is basically an entity, and you can see that a ton of these different types of entities are related to other entities, like let's say I'm related to the GNOME Foundation, So people who are already in the GNOME Foundation can be imagined to be circles, and being in the GNOME Foundation can be identified as a relationship. So that's the relationship I share with all the GNOME Foundation members, as an example. So you can see that a lot of things fit into this graph model. So, okay, so I said that graphs can help represent information. I can run queries on them, and I can also pull out a subset of information from them. Cool, that's cool. But why not use a relational database like SQL or something else? So, a couple of reasons for not using SQL and using a graph database over here are as follows. So the first one is graphs are very dynamic, so I can easily add new relationships or which can correspond to like a column in the table, and I can add new relationships, and I can even visualize the data very well. So I can, for example, if I have a table, I'll have to look through each row and probably figure out like how each entity is related to the other. But if I have a graph, it's like a drawing. I can figure out information right from there. So it's very intuitive, and it's very fast as well. Even though speed doesn't matter so much for our application, but it's good to note. And it's very agile in the sense that I can put down queries really fast. I can use clicks of mouse buttons to filter out information. And yeah, that's a couple of motivations for going for graphs instead of SQL-like databases. So, okay, so now let me get down to the tool that I wrote. So I'll first talk about what the workflow is for the tool, like how the tool works or how to use it. And then I will be giving a quick demo on the tool, basically. So, okay, so what Continuous does is it will build a nice big JSON file which has each module and the build status, basically. So it says, okay, module A and the build status is passed. Module B, build status is failed. So it builds a nice JSON file from there. So this is the first step. So what I do in the application is I pull out that JSON file from GNOME Continuous. So that gives me all the information I need about modules. So now I know which modules are good to go, which modules are not so good to go, which modules need my attention. Okay, next step. I talked about 2 or more modules depending on a single module. So they might have a dependency, like there might be a rendering library that multiple games depend on. If that's broken, multiple games can be broken. So that's like a dependency. So what I do next is I go to the github.com/project, and then I pull out the dependencies that the application depends on. So there's a config file in each GitHub project, and I pull out the dependencies from there. So now I have 2 sets of information. Number 1 is which modules have their builds passing and failing or whatever, and the second information is what each module depends upon. Okay. Next step, now is the time to build something interesting. I have all the information I need, now I will be building a graph. So I build out a graph, so like I mentioned, circles are nodes. Each entity or circle or node is one piece of information, and the entities would be the game's modules, and another entity would be the dependencies that we pulled out in the second step. And we build a graph out of it. The relationship obviously will be, if a game has a dependency, there'll be a line between the two, which represents a relationship. So I guess people listening to me in this talk would have a rough idea on what we get out of this. So now we have a graph. Now we have all the information that we got from step 1 and 2. Visualize, so it's right in front of me. I can now see all the modules, all the dependencies, all the relationships as a graph. So bear with me, I will give you a demo, but this is just to show you some stuff. Alright, so now I can run queries on this graph. That's the interesting bit. So let's say I care about 25 games, and the first thing that I want to do is pull out the build status and then build out this graph. And now I want to query the graph for the modules that have their builds failing. So those are the ones that need my attention. So I'll pull out the modules that have their builds failing, or timing out maybe. And then there might be some modules that GNOME Continuous isn't looking at, so I can even find out the modules that have no build information or they're missing from there. And what next? Now I have, let's say, some modules that are failing. So what I can do is find out the common dependencies, probably go back, look at the modules, and then now I have this as a reference, which I can use when I'm debugging modules. So let's go to a quick demo and we can see this in action and probably understand this better. So the demo is here. So I have the demo on YouTube as well. You can watch it directly from there, or you can see it over here. Okay. So first thing I start is Neo4j Community Edition. So Neo4j is ready, and that's my GitHub project. The GitHub project is right here. Let me pull it up for you. Okay, so this is the project, Sahil/GNOME-games health analytics. You can find all the code and how to use it. This is a sample graph that you can see, and I can also, oh yeah, let me talk about the motivation, like how did I get the idea for doing this? So yeah, so there was this email from Ibesi on the GNOME desktop mailing list. Let me read it out for you. It says, in short, we're building the core GNOME and some applications. Every time something gets committed to git.gnome.org, we're also doing various tests, like smoke testing the session, running applications, and building VM images out of the build process. What we need now, though, are build sheriffs. So people that watch this build process and ensure that it continues smoothly. So every maintainer is expected to be on IRC on the testable channel, but sadly that's not the case. Many of us are not doing that, and that means they missed the notification that something broke the build. So we cannot always send emails to the last committer of a broken module because GNOME is a complex project, and a change in dependency may indeed break your project even if you didn't know about it. So that's the problem. People aren't able to follow testable, so there are many issues, right? For example, I have a full-time job. I cannot be on IRC all the time, so I probably check stuff on the weekends, like just make sure everything is sane on the weekends. So I cannot be on the channel all the time. I cannot be there for 24 hours. I cannot respond to problems like this immediately, so they might miss me. So that's the reason I have this project over here. So okay, so getting back, that's, you can see there's setup over here. You can set it up on your laptop yourself, and you can also contribute to this. I appreciate if I get some contributions. So that's the project right here. So I have already pulled it out. So okay, so now there's this configuration file. This is a JSON configuration file. So over here I can specify the modules that I'm interested in, and these are not necessarily games. Could be anything, any GNOME module, and I specify all the modules over here, and these are the modules for which the graph would be built. And I specify for the date for which I want information to be pulled out. I also put in the configure.ac file link, like where should the modules be pulling out the configuration for dependencies from. So that's something I do in the configuration. You just have to change things over here and build the project. So you can see all the modules over here. It's extracting configuration for each one, so it's basically pulling stuff from here, from this link, and for this date. So you can see, oh, it's building graph, it's running queries, and I should have a graph really soon. All right. So okay, this is the Neo4j console. Okay, and you can see now I already have some modules that have come up. So I have these 4 node labels. I can read them off to you because I don't think they're visible. So there's build fail, build information missing, build passed, build timeout, dependency, and game. So each of these are basically nodes, entities that I talked about before. So I have a node that is called build failed, for example, and this entity has a relationship to all the game entities which have their builds failing. So there's a relationship between build failed and the games which have their build failed. So that's one node. There are a couple of others, and there's game node as well. So each entity would be identified as a game, would be of this color, this pink color. Okay, so you can see pink color are all game modules. The red one is build failed. Okay, and there are also relationships over here. So there's a status underscore is relationship, and there's a used by relationship. So status underscore is used to identify the build status. So build passed, build failed, build timed out, stuff like that. And used by is used to identify the relationships. So which games have their dependencies on something, or in simpler terms, which dependencies are used by the game nodes. So that's basically information we need to proceed. So you can see, okay, these 2 games have their status failed, and all I have to do is just double click on any game to pull out the neighbors of this node. So I saw that, okay, GNOME Taquin and GNOME Sudoku have their builds failing, and I just double clicked on the Taquin node, and I can see, okay, there are 1, 2, 3, 4 dependencies of Taquin. And I can also see that GTK plus 3.0 and glib 2.0 is shared by Sudoku and Taquin, and both have their builds failing. So this gives me some information here. So that's interesting. I can see GTK plus 3.0 and this is shared. So if GTK plus is broken, which shouldn't be the case, but just in case, if GTK plus 3.0 is broken, obviously it breaks me, and it breaks Taquin and Sudoku, both of them. If glib is broken, it also breaks both of them. So now I have a couple of directions on how to debug the broken games. So I can look at GTK plus first, I can look at glib first, and then probably go on and look at, let's say I'm debugging Taquin. I already looked at the common dependencies. Let's say I didn't find anything. I go to the dependencies that are unique to this game, and I can do another thing too. So I can do some pruning over here. So let me see if I'm showing that already or not. Okay, it wasn't shown. Let me go back. So what I can do over here is I can prune out. So let's say QQWing has a dependency on Sudoku. Now I want to make sure that in my analysis I take care of looking at QQWing. So I just double click on QQWing. That gives me the immediate neighbors of QQWing. And then I find out, oh, QQWing is just dependent on Sudoku, so I can't prune out looking at that dependency. There might be another dependency like GTK plus 3.0, which is used by a ton of other games. So when I see that there's a game which depends on GTK plus 3.0 and has its build passing, I can just forget about even thinking of GTK plus 3.0 as a problem for breaking my builds. So I can prune out stuff like that, which makes my analysis of failures easier. So that's the point. And I can see, oh, is there any node that has build information missing? So this wasn't really the case, but I just added something, a fake or a broken name in the config, so we could just demonstrate this. So all the games have their build information on continuous. So are there any builds timing out? So I didn't have any game that was having its build timeout, so I found photos. So photos had its build timeout, so that's another example. And okay, what about the good ones? Okay, so there's a ton of nodes which have their builds passing, so that should be the case. I should see a lot of games that have their builds passing. So a lot of them have their builds passing, that's good, I'm happy. So now what you can do is, you can double click on nibbles, for example, and now I can see, oh, this is a little complicated over here. But what I could see is all the dependencies on nibbles and even the relationships of those dependencies on the other games. So, of course, that's 25 plus games over here, so it's very cluttered. And I can also see just the dependencies. I can double click on any dependency and find out its immediate neighbors. For example, QQWing, it just has Sudoku. And I can see all the game nodes, for example. So, there are so many games. I can double click on any game and find out its immediate dependencies and stuff. Okay, the interesting part. Now I want to find out the dependencies which are unique to the games whose build is failing. So it's like QQWing depends on Sudoku, and it depends on just Sudoku. So if QQWing is broken, it will be breaking just Sudoku. So I want to find out which are the dependencies which are unique to the games whose build is failing. Let's see what happens when we run this query. We saw Sudoku was broken initially. I expect to see QQWing. Oh yes, so I see there are just these two dependencies, and there was TACWIN and Sudoku who had their builds failing. So it's just these two which are unique to a game which have their builds failing. So now I must check both of them if they are problematic, or is it Sudoku who has a bad comment. So this gives me like directions on how to debug problems, and I can save time. So okay, let's see what we do. So next example, okay, let's see. So we have TACWIN as well. Okay, so now we do something different. We look at dependencies which are used by the second module which are failing. So the second one is TACWIN. So we're looking at dependencies used by TACWIN, which are also used by games whose builds are passing. So the dependencies which are common to the failing and passing modules shouldn't be a problem. So the dependencies which have some games whose builds are passing, that means that they didn't break anything. So it's supposed to be a problem with the module itself. So TACWIN has all dependencies of TACWIN are dependent on other games which have their builds passing, so I can forget about them. So there's no dependency breaking TACWIN. I straight away know that there's a bad commit which went to TACWIN which broke it. So let's go ahead. Okay. So what is our analysis now from this graph, from this query that we run on the graph? So Sudoku might have a bad commit, or it might be broken by these two dependencies which are unique to just this guy. TACWIN doesn't have any unique dependencies, so it's highly probable that TACWIN has a bad commit that broke it. So now I have like dedicated information to look at. Okay, so let me show you a demo over here. So we have other dependencies. G should be depending on other guys. That's the reason why it wasn't shown. And they have their builds passing, okay? So the dependencies that were common to passing modules were not shown in the pruned graph that I got from the query. So that's about it for the presentation. And all I'd like to say to conclude is may the graph be with you, and that's all the information about me. You can see me around on IRC as SSAREEN, or you can drop me an email on ssareen@gnome.org. You can connect with me on Facebook and GitHub as well. There are links right down there. So I miss you all. I couldn't get to the conference because I couldn't get an emergency visa at the German embassy in Dublin. So I'm really sorry about that, but that's the best I could do for you. And I hope to see you in the next GNOME conference. And bye for now. Have a fun time.